Hey, and welcome back to the second part of the first episode where we built a simple LLM agent. In this series we will build LLM agents using TypeScript, LangChain, Ollama and AWS. And in the previous part of this series we built a simple local LLM agent using Ollama. That was all local, nothing in the cloud. And in this episode we will build a similar structure, but this time we will build it in the AWS cloud using a Lambda. So it will be a serverless LLM AWS agent, but we'll still keep it simple. So we'll keep the same structure that we did last week, but let's dive into it. So I opened a fresh project and I'm gonna initiate the CDK here with CDK init and then language TypeScript, as we're using TypeScript. And as this is initiating the project for the tools that we need for CDK, now it's done. We're gonna add a couple things extra to last time. So last time we made it all local using Ollama, and we had Ollama running in our device so that we can use the LLM. So this time we're using AWS, we're gonna use Lambda, and we're gonna use Bedrock, and Bedrock is the LLM that AWS provides. So instead of Ollama, we will have Bedrock, and we're gonna add another thing. So last time we did invoking, and this time we're gonna stream. And while we're streaming, I'm also adding some memory so that we can have a conversation and the LLM agent can keep track of what we had in our previous responses. As normally when you instantiate an LLM, it does not have any memory, so it cannot keep track of a conversation. So we'll add those things here as well. And so what we're gonna do is first install a couple dependencies. So the add LangChain AWS, because we need the Bedrock LLM. Then we're gonna add the LangChain community. We will use the chat history for DynamoDB. That's provided by the community package. Then we'll have LangChain core and LangChain LangGraph and LangChain Zot and ESBuild. ESBuild is for building the Lambda. So once we install these, we'll also need to install dev dependency. So just a moment until this is installed. And we'll still keep it simple, so it will still be an agent that has a single tool, which will be the tool to check the date time, but we'll add memory this time, and it will stream, and we'll use AWS Lambda function URL, which means that it will be a Lambda which has a URL that we can call, and we can send a request to, and we'll get a streamed response back. So the dev dependency that we need to install is add_type/AWS Lambda. So once we have that installed, we are ready to start building. So then I'm gonna add a new directory. Let's have it correctly named, agent. We'll have an index file, and this will be the file with all the code for the Lambda. Then we'll have a utils directory, and inside of there we will have the same files that we had in our local agent. So we'll have a graph, we'll have a state, we'll have a file called tools, and we'll have a model file. So I'm forgetting one, and that's the prompt.ts. So that's all the files that we also had in our local agent, and we're pretty much gonna have the same structure as I said. So a couple things will be identical, but minor things will be different as we're using the thing. So to start, let's just start with everything that's the same. So in the tools, we will have exactly the same tools. So if I copy that over, so this is exactly the same tool. We're using the current date time tool, which will get like, no input, and then it will do date.toISO string, and then have this as a state in our state, and then it will know like, hey, this is the time, and it can tell us what time it is. So we have a description and a name, and we'll add this in the tool registry as we did last time. And then the agent will be able to use this tool and tell us the time whenever we have a conversation and it's relevant. So the tool is exactly the same. So what's also the same is the state. So we can again only have like a current date time, and we're extending the ZOT state that already has the messages in there. So we don't need to add that. So the state is also exactly the same as we had. Then we're gonna go to the graph. Well, let's do the graph later actually, because the prompt is also the same. We're gonna keep that, just copying it over from that other file. So we have the prompt, which is again exactly the same, which says you are a helpful AI assistant named Faruk. You have access to the following tools. Then we'll add here all the tools out of the tool registry, and we'll advise it to use the tools when answering the questions. So then we have the prompt ready, we have the tools, we have the state, and then let's go to the model. And as I said, last time we were using Ollama, which was locally, and this time we're not, we don't have the local Ollama running, so we will use Bedrock. And for that, we are importing the chat Bedrock converse from the LangChain AWS package, which is pretty much the same, but this time we're using the AWS variant in the cloud. And well, the difference also, last time it was free, and this time when we inference, it will be, it will cost something, but it's very cheap. So I did couple, I did pretty many of these invocations, and I have a very low cost on it. So it's not something that you need to be scared of. It's like a couple cents after so many invocations. And well, depends on, of course, what you are sending in, because it's also counting the tokens that you sent in. But do note that it can incur cost. But if you're just prototyping something, it will cost almost nothing. So don't worry about it too much. But let's go to the code. So last time we were having a large a language model type that we created ourselves, but this time we're just going to use the chat Bedrock converse, which is already a type that is provided, and we're creating, instead of a new Ollama chat, well, it was chat Ollama, I think, we're going to use chat Bedrock. We will add a model here, and we'll get to this later, but we need to put the identifier here, which will tell this this construct which exact model we want to use. So we will be using, I think, Anthropic's model, so we will add identifier for that one here. Then we have the region where we want it to be. We have a temperature just like the other one to decide how similar the response time. And we have a max tokens, we have a max retries, we have a max concurrency in here. You don't have to add these, but I just add them just to not let it get out of the hand, because you never know what happens. Maybe it's gonna do, I don't know, thousands of concurrent requests at a time, because it is set to infinity if there's like no value provided. The default is infinity. But we also need to set streaming on true. So this is our model, our brain, and then the tools around it will be used so that the brain can actually act as an agent. But in this case, the Bedrock will be our brain. So then in the graph, it will be pretty much the same, but last time we were filling this one inside of the index file, and now we're just going to fill everything inside of the graph. So we're importing the create react agent. That's the pre-built graph that LangChain provides. Then we're gonna do the get model here. We're gonna get the prompt, we're gonna get the state, we're gonna have the structured tools here. So let's add these here. So we have the tool registry now here. And then instead of having a function that requires all of these parameters, we're just gonna have a create simple agent, which will return a create React agent with the LLM model inside of it. We will have the tool registry in there, the prompt and the state. So now basically we have the same construction that we had with our local agent, and the file that remains is the index. So the index file will be a little bit different than what we had last time. Last time we were just running a local file. This time the index will be the code for a Lambda, and it will be a Lambda with the function URL, and it means just that we can call this without having an API in between or something in between. And then we will make it so that we can stream back the responses, and we want to stream back the responses to have it a little bit more interactive, so we don't have to wait long for an answer, and we can already see as the words come in. So what are we gonna get? We want to create simple agent that we just added in the graph. Then, as I said, we're also gonna add the memory to keep track of a conversation, and for that we're gonna add the DynamoDB chat message history. And for those who don't know, DynamoDB is like a database that AWS provides. It's a NoSQL database, and we'll also create that in our construct in a bit. But know that we will use this to store our conversations, and then whenever we invoke this Lambda again, it may be like hours later, but we have like the same session ID, we'll add the session ID as well. Then it will retrieve the conversation from memory or from the DynamoDB database and add it inside of the context of the model, so it will know of these previous interactions. And we won't make this very complex, so now I'm just gonna add it all inside of the context, but it can be that if you have too many messages that it's too much to fit inside of the context, and then you do need to do more sophisticated stuff, but we won't be doing that. Then I'm also gonna add the AI message and human message provided by LangChain, and you don't need to do that, but I just like to use those constructs instead of hard coding it there. And finally, we will have a buffer memory, and the buffer memory will be used in combination with this DynamoDB chat message history to get the messages out and then put it inside of the context. And if you normally use this with just the converse model, you can directly plug it in and you don't need to do what we're gonna do, but we want to have the React agent so we can use some tools, and that's why we're just gonna use it a little bit different. Then I'm getting a little bit of help, I see, from Copilot. So what we're gonna use is the AWS Lambda streamify response, which actually means that this will be a Lambda which can stream back responses. And then let's configure this. So we will have an event. The event will be the incoming event, so whenever we ask a question, that will be the event. And then we'll have a response stream, and the response stream will be sent back to the user that initiated it, or system, whatever it is. So I'm gonna log the incoming event time, and I'm gonna use this as the time the question was asked by the user. I'll put this inside of the database, so whenever we look back we can see like, hey, this order, the questions came in inside of this order, and this was the timestamps for each of the questions. And so whenever the question comes in, I'll note that time as this was the time that the question was asked. Then I'm gonna also set the response stream, the content type of it, to plain text, as we're gonna send back plain text. And then because we're expecting an event, And as I said, we need the session ID to keep track of the conversations. We expect an event, and inside of there, I'm going to say we expect a message, so the question that was asked, and there should be there should be the session ID in there. And I'll be adding this now hard-coded, but you could have an application that generates this and then adds it to a database and retrieves it for each user. So whatever you want to do about that. But for now, I'm just gonna check inside of the event. I'm gonna expect that it has a body. And if it doesn't have a body, I'll add some very simple validation. We're gonna say, hey, body is missing. We'll write that back to the stream, so this will be received by the user. And then we'll also do kind of the same. So we also want to check inside of the body if we have a message, which will be the question, and a session ID. And if there is no session ID or the message is missing, we'll say, hey, message or session ID is missing. So far we are validating the incoming event, and if it doesn't, you can do more validation, of course, but this very simple validation that we check, like, hey, does it have a question, and do we have a session ID? Then we want to initialize the chat history with the session ID that we received. So we're receiving a session ID, and then we're going to retrieve from DynamoDB with this session IDs. This will be like a partition key, as they call it in DynamoDB. And then we'll retrieve it, and what we'll retrieve, I'll also show it inside of the console, because we can actually check what it will save. But it will retrieve like a list of messages, and those messages are the messages that have been exchanged between the agent and the human in this case. So we'll create this, we'll get this history table from the DynamoDB table. And once we have that, we need to buffer that into memory. So we'll just add that as chat history. And now we have this buffer memory, which I call memory. And we will use that to get the messages inside of there and pass it on to the LLM so that it knows the context. And as I said before, and I'll add it here in a comment as well, we're loading the existing chat history, and this can exceed the token limit. So if it's like too many or too long, and this is only for demo purposes. So we're getting all of the messages, and we have the chat history now here. And I'm gonna just add this all inside of the invocation that we're gonna do, so that it just knows, like, this is the course of actions that has been taken, or conversation that has been taken. So then we'll create an agent, which is the create simple agent that we created here. So we're just using that graph, and once we have this graph, we can call this graph. And then last time we were invoking it, and this time we're gonna stream it. So let me copy that in. So we're gonna await agent.stream, and then we'll add, we'll have two parameters. So first one, we're adding the messages, and in the messages array, we're adding the chat history. So it will have like human AI messages, and we end it with a human message. So this will be the last message that it will receive, and it will then answer this last message, the last question that we're asking. And then to keep track of the history, we're adding the session ID inside of the configurables, and the session ID will then be used for the DynamoDB history. So finally, we're also gonna put the stream mode on messages. You can have different values for this. So you have values, updates, messages, custom, and debug, and each of them have the different type of output. But I just want to have the message for now, so I can stream that back to the user. So what we're gonna do is invoke it, and then we're gonna get chunks back in this case, because we're streaming. So it won't give us back the entire response in one time. It will give us bit by bit, and I want each of these bits to be messages so that we can send these bits immediately to the user. So let's do that now. And as I said, we're gonna get stuff in chunks. So we're gonna have like this let response, and we will collect and write all of the chunks inside of this response so that we finally also have the full response, and we will save that ourselves into the chat history. So let's first, so we're gonna for await const chunk of stream, so every chunk of the stream, we're gonna get inside of this chunk, we're gonna get the first object, because there will be two objects in there. The second one just has some details about the call. So in the first object inside of this chunk array, we want to have the content, and the content, as I said, will be part of the answer, which will be a string, and we're gonna add this to our response, and we're gonna write it back to the stream. So we're collecting it here so that we can save it into the chat history later, and here we are writing it back to the one that made the call, so it will be streamed inside of the stream, and I'll show that later as well. So then basically now we've answered it back to the user, and we can actually end it, but as I said, we also need to store it inside of the memory. So we're gonna await the memory and the chat history, and we're gonna add a message, and we're adding a human message, which was the question, and I'm adding the timestamp with the question date time that we took here. So I'll be adding that here, which will then be added also inside of the database, but I'll show you that as well. And you can add different kind of variables here, whatever you want. So then we'll also add the AI message, and the AI message will be the answer of the AI, and we'll add a new timestamp here. So whenever the full response has been given, we'll add the timestamp of the full response. And then finally we need to end the stream. So we'll end the stream here. And basically this will be all the code that we need to run inside of the Lambda. So this all will be now our agent, but we can't deploy, we can't use it yet because we still need to deploy everything. And to deploy everything, if you've used CDK before, we need to make some of the constructs here. So we're gonna do that as well. Gonna add like the code, and once we have everything done, we can deploy it. And so if you haven't used CDK ever before, I would say watch maybe the first episode of one of my series that shows you how to configure it, because you do need to configure it and get like your access key and secret key. And once you've configured it, you can just execute the commands as well. But if you have not, know that you need to do that as well, so it won't work just as it is. So what do we need? As I said, we're gonna use DynamoDB, we're gonna use Lambda, so let's add of those here. So I'm also adding IAM because we need to set permissions, so we'll use IAM, which is about permissions. Then we have DynamoDB, we have Lambda, and we have Lambda node because we're using Node.js, and that just adds the packages to the thing, and else you have to do it yourself. So we're gonna use the Lambda node version. I'm also gonna add log from AWS logs, and that's just to control the log groups, because log groups if you're gonna add stuff and then remove it, log groups don't get removed by themselves, and they have, I think, retention of 2 years or something like that. So I'm gonna add that as well, so if I wrap this all up, that it will remove that log group. So then I'm gonna add the inference model that I'm gonna use, and I'll at the end, when we're gonna inference everything, I'll also show you where to get the models. Also have a look inside of the AWS account. So for now I'm just gonna add it, and it might seem a bit weird, but I'll tell you where to get it later as well. So the inference model that I'll be using will be the the EU Anthropic Cloud 3.7 Sonnet model. So this is the identifier for it that we'll be passing on to our model here. So this will be filled in with part of this. So it's a bit longer than this, but this part we need to know. So this can be changed. The other parts are pretty much the same when you use a different model. So this is the inference model. Then we also need to add a DynamoDB table for the chat history, where the chat history will be stored. So I'm adding a memory table, which will be like a history table with the name history table. It will have a partition key, and that partition key is session ID. And this needs to be the same as the partition key that we're using here. So I'm using the session ID here as partition key, and that's the same here. So this will be the partition key by which we can also find it then inside of the database, but the session ID will be the identifier for it. Then I'm just going to use paper request, and then on removal I will just destroy this database just to clean it up. So you don't need to do that if you're in a different environment. Then let's create the Lambda, and well, first we'll create just a normal Lambda, and then we'll add like a function URL to it. So the stream Lambda is just a Node.js function. We have a function name, we have an entry, so that's in the agent index. So this will be the file that will run inside of this Lambda. I'm just adding a little bit more memory, 512. It can be a bit less, I think, but just to make sure that we have a timeout of 60 seconds and that everything is done within those 60 seconds. Then the important stuff, the initial policies, so the permissions for this Lambda that it needs to actually invoke Bedrock is Bedrock invoke model and Bedrock invoke model with response stream, as we want to stream back the response. So if you don't have these two permissions, then you cannot use Bedrock, so then the agent will not work. Then finally we need to add the table name, which we are using here. So for the DynamoDB chat message history, we're adding that inside of the environment variables. And then finally the full identifier for the Bedrock inference profile will be ARN AWS Bedrock. And then you have the region that you're in. Well, I'm in the EU region. Then you have your own AWS account ID. So that well, if you use this as well, this will just get your region and account ID on deployment. So you can just use this. It's also nice always, because if you have different accounts, and you have changing environments, then you can just keep it like this as well. You don't need to change it every time and have it in props or anything. But then we have the inference profile / and then we have that model identifier, and that model identifier we added here, and I will show you once again after we have deployed everything where to find this. So if you want to use a different one, or maybe you're in US region or maybe a different region, where to find this identifier and how to get access to using Bedrock as well. So finally, I'm adding a log group. As I said, I'm only doing this so that I can clean it up. So you don't need to do it, but it is good practice to actually do it, because then you have control over it and it's inside of your stack. You don't have orphaned resources. So I will just add a log group, which will be destroyed once I am actually removing this. So far we just created a Lambda, but we also need to grant it permission to use this memory database. So whenever we are running inside of the Lambda, we're going to say, hey, memory table, grant read-write data, so it can write and read while in the Lambda. And finally we need to add an URL, and the URL will be in this case used to communicate from the terminal here with this Lambda. And then we're gonna say stream Lambda add function URL, and we can add the authentication type, so you can add IAM here if you want. For example, if you have connected to for example Cognito, Amplify, sorry. If you're using Amplify and or any other thing, and you want to use authentication to keep this secure, then you can add one. I won't be adding that here, as I also will be deleting this function after this video is recorded. Then the invocation mode, I'm gonna set it to a stream. You can also change this to buffered, which will be like invoking, but I don't want to do that because I want to have the chunks immediately. Then we also have to add some cores, like what is allowed. So we're gonna say allowed headers, we need to have content type, because we're gonna add content type is plain text. And for now we're just gonna say all HTTP methods are allowed, so you can do get, post, all of this stuff. You can restrict it however you want, but as this is a simple demo, we're not gonna do that. So basically now we have also the infrastructure ready to deploy our Lambda, but I'm gonna add one final thing just to make it a little bit easier for myself. I'm gonna add the CFN output, which will just output this text with the function URL inside of the terminal here once we deploy, so that I don't have to look it up. So now we have everything that we need. This will be the infrastructure, and then here we have the logic for the agent, and we can now deploy this. But before we can, well, let's just do it. CDK deploy. Oh, something is still off. Okay, I see we need to install some dependencies. Let me quickly check. Yeah, we need to install the SDK for DynamoDB. Which is getting used by the community package. So let's see if that's okay. Might have to install another dependency. No, okay. So let's see what we expect to deploy. So we have AWS Lambda with the invoke function URL. It will be assumed by Lambda, of course. Then it will be allowed to do all of these actions on the DynamoDB database, so basically everything. And it will be allowed to do Bedrock invoke model and Bedrock invoke model with response stream. So that all looks good. I'm gonna say yes, let's deploy it. And then while this is deploying, let's log into the AWS account and see what you actually have to do before you can invoke the model. We can already deploy, of course, our Lambda, but yeah, there are a couple questions, of course. Where do you get this identifier for the model, which we will have a look at? And if you haven't requested access from AWS for your LLM model usage, you won't be able to use it either. So we'll have a look at both of these. First we'll have a look at the identifier, and then we'll look at how to request access to use the model. In the meantime, this will be deploying, and once it is deployed, we can actually use it. So let's head over to the other screen. So over at the browser, I went to support regions and models for inference profiles, and I'll add also this link inside of the description of the video. But on this page you can look up that identifier that you need. So for example, let's say that I want to use the global Cloud Sonnet 4.5, which I actually might want to use, but here you have the identifier that you can use. So if we look at, so this is US, and then we go to EU, and then in EU 3.7. So if you compare this to what I had there, it should be the same. But if you want to use a different one, well, you can just get it here. So I'll add this link to in the video description. This is just the page where you can look it up, and the inference supported per region, so that you don't need to look for it like I did, because I was a bit confused about it as well. But just now I'll add the link, you can just look it up, it's simple as that. So then let's have a look at what else you need to do, because now you may be knowing what identifier you need to use to actually use the model, but you won't have access to the model yet. So for that, we're gonna go to Bedrock. Inside of Bedrock, inside of the AWS console, just for if you didn't know where we are, we're in the AWS console. We're gonna go to Bedrock, and once we're inside of the Bedrock console, we're gonna go to Model Catalog, and inside of the Model Catalog, you see all of the models that are available inside of the region that you want to deploy in. And I want to deploy inside of the EU1, and inside of the EU1 I have access, well, not access yet, but I have the ability to get access to these models, and I have already access to Cloud 3.7. But let's say that you don't have access yet and we want to request access to a different model, maybe a first model. Let's, for example, let's go to this one. I want to get this one inside of my thing. I want to get access to it. So here, I don't know if you can read it, but very small, it's written available to request. I'm just gonna click on it. It says request model access, and you also have it here on the left, it's just model access. You can then modify this access. I already have Cloud 3.7. Let's say I also want 4.5. So I will do next. Now I will submit it. And after submitting, you'll wait like a couple minutes, maybe even immediately, but you'll have access to this LLM. And before you do this, you actually cannot call the LLM. So this is a very important step. If you just deploy the Lambda and you have everything set up correctly, but you don't have access here, you won't be able to use Bedrock. So it's very important, but very small step to do. Once everything is done, and let's see, and you see a message here that they will be retrying this page soon, so it will be all simplified as I understand it. So it's still in progress, this one, but you can see here also the state. I have access granted on this one, and this one is still in progress, and I think probably in a couple minutes I will have access to that one as well, but I don't need it yet now because we are just going to use the Cloud 3.7 Sonnet. So in the meantime, we can also have a look at DynamoDB. So we can see that there's a history table now here, and it uses a primary key which is a session ID. So I know it's very small, but maybe I can make it a little bit bigger. So we have a session ID, which is the partition key, and we're not using a sorting key at this point. And at this point it's also empty, but we're gonna have a small conversation, and then we'll come back to this table as well, and we'll have a look at what's inside of the database. So let's switch over again to the editor because everything is deployed, and now we can call the agent and check if it's actually working and if we get the streaming response back. So we're again over at the editor, and as you can see, the agent has been successfully deployed, and so the CFN output also gave us the URL here for the function URL. So what we can do now is send a post request to this URL with a question and also a session ID, of course. I'm going to use git bash for this. So I'm going to do a curl post to this URL that we got. Then the content type in this case will be application JSON, as I'm sending a JSON object. And then I will add this message here, which is, hello, my name is Faruk Ada, can you introduce yourself? And then also add a session ID, which will be a string S1234578 and 9. So I will send this now, and let's see if we get the response back, or maybe something goes wrong. So as you can see, we get the response streamed back into our terminal. It's saying, hello Faruk Ada, it's nice to meet you. I'm FarucciBot, an AI assistant designed to help you with various tasks and answer your questions. I can provide information, assist with different topics, and use tools like checking the current date and time to give you up-to-date information. Would you like to know what time it is right now, or something specific I can help you with? Well, let's keep the thread. So let's keep the session ID the same. And then I'm gonna say, can you tell me what time it is now? And could you also tell me a short story about me that you make up now? Oh, I see that I removed the session ID here by accident. Let me see. Comma session ID. So we're keeping the same session ID. So it says, let me check the time for you. Then it waited a couple milliseconds maybe and gave the current date time is October 13th. It's 6:12 p.m. which is not my exact time, but it's the time that it's getting on the server, so that's about right. And then we get the short story. So as you can see, it's saying Faruk Ada always had a curious mind, so it did also remember my name. And then the final thing I can say, let's remove this, and I say, what was the first question I asked you? The first question you asked me was, hello, my name is Faruk Ada, can you introduce yourself? So as you can see, we now have an AI agent that can check the time. And once again, maybe not the best tool, but you can always swap out the tool to whatever you like. And it is responding, and it's also keeping track of the conversation. And we are able to stream the responses in. So then one final question remains. Should people subscribe on my YouTube. Sadly, he doesn't have a specific information about my channel, but if you did like the content and you enjoyed it, like and subscribe, and we'll be back with more sophisticated agent every time. So I switched over to the console one more time. As I said, we'll have a look at the database, what's stored there. So let's look inside of the DynamoDB database. As we can see, we do have a conversation here with S12345. So this is the session ID that we added inside of the calls that we just made through the terminal. And if we then open it up, we can see it has an array in here called messages, and that will just have all the messages that we exchanged with the AI. So here was the first question that I asked. Hello, my name is Faruk, can you introduce yourself to me? And also the timestamp that I added. So if you would add additional arguments, they would all show up here. And you can see that this is of type human, and then we have the type AI, which is the response with a different timestamp, and so on. So this is what gets saved inside of the database, and this is just one of the implementations where we use the history table, and we'll also use different kinds in later things. So, but this is what we're actually saving. So this is also what gets fed back into the LLM to keep track of the conversation. So if we then ask, hey, what was the first question? This will all be put into context. And as I explained, once this gets really big and it doesn't fit inside of the context window anymore, then you need to do more advanced stuff, and it would be even better if you started doing advanced stuff from the start, but we're building simple stuff to start with, so that's why we're not doing that yet. But thank you all for watching. If this was something you really liked, then really don't forget to like and subscribe, and maybe press that bell button, and I hope you all have a good time until the next time. Bye bye.